for electrical contractors looking to expand their expertise into data wiring and structured cabling. Several educational avenues are available. Online resources offer a convenient starting point. BICSI, or Building Industry Consulting Service International, provides certification programs, training materials, and webinars covering all facets of structured cabling. TIA, the Telecommunications Industry Association, offers standards, educational resources, and certification courses focused on telecommunications systems. Fluke Networks offers free online training courses, application notes, and white papers specifically on data cabling. Panduit provides webinars, technical articles, and white papers that discuss structured cabling solutions. CommScope offers online training modules, installation guides, and technical support related to their cabling systems. Educational institutions present another pathway to acquire knowledge. Many community colleges offer certificate or associate's degree programs in telecommunications or electrical technology. Specialized trade schools dedicated to electrical and telecommunications training offer focused courses on data wiring and structured cabling. Private training providers such as Training the Street and EdgeCom offer comprehensive courses on data cabling and structured systems. Trade organizations also play a significant role in providing educational opportunities. The National Electrical Contractors Association, or NECA, offers educational programs, certification courses, and industry resources specifically for electrical contractors. Associated Builders and Contractors, or ABC, provides training and certification opportunities for construction professionals, including electrical contractors. The Institute of Electrical and Electronics Engineers, or IEE, hosts conferences, workshops, and publications on various electrical and telecommunications topics. Vendor certifications can enhance your credentials and demonstrate expertise. The BICSI Registered Communications Distribution Designer, or RCDD, certification demonstrates expertise in the design and implementation of structured cabling systems. The Fluke Network Certified Cable Testing Technician, or CCT, certification validates competency in cable testing and certification methodologies. The Panduit Certified Cabling Installer, or PCI, certification confirms proficiency in installing and testing Panduit cabling solutions. Additional considerations include attending industry conferences and exhibitions to stay updated on the latest technologies and best practices by participating in industry events. Network with other contractors to seek advice and referrals from experienced electrical contractors who specialize in data wiring. It is also critical to invest in measurement and test equipment, acquiring the necessary tools such as wire mappers and cable testers to ensure proper installation and certification of data cabling. To delve deeper into specific areas, consider exploring resources that cover grounding and bonding, as proper grounding is crucial for the safety and performance of data cabling systems. You can refer to the National Electrical Code, specifically Article 250. This provides detailed requirements for grounding and bonding electrical systems. The TIA 607 key standard offers guidelines for telecommunications grounding and bonding infrastructure. Learn about cable types and categories to understand the different types of data cables, such as Cat5e, Cat6, Cat6a, and fiber optic cables, and their respective performance characteristics. The TIA 568 series of standards specifies the requirements for various cable categories. Become familiar with cabling standards. The TIA 568 series of standards provides comprehensive guidelines for structured cabling systems, including cable performance, installation practices, and testing procedures. For fiber optic cabling, refer to the TIA 568.3 D standard. Understand testing and certification. Learn how to properly test and certify data cabling installations using industry standard testing equipment. The TIA 1152. A standard specifies field test requirements for balanced twisted pair cabling. For fiber optic testing, refer to the TIA 526.14 B standard. Delve into network topologies, such as star, ring, and mesh topologies, and their impact on cabling design. The IEEE 802.3 standard defines Ethernet standards, including network topologies. Learn about Ethernet standards, including 10 base, T100 base, TX 1000 base, T and 10G base, T and their cabling requirements. The IEEE 802.3 standard defines Ethernet standards, including cabling requirements for different speeds. Understand Power over Ethernet, or PoE, and Power over Ethernet Plus, or PoE Plus, technologies which allow you to power devices over data cables. The IEEE 802.3F standard defines PoE, while the IEEE 802.3 standard defines PoE Plus. Become familiar with cable management practices, including proper cable routing, labeling, and termination techniques. The TIA 569. The standard provides guidelines for telecommunications pathways and spaces. Learn about troubleshooting techniques for identifying and resolving common cabling problems such as opens, shorts, and impedance mismatches. Use cable testers and diagnostic tools to troubleshoot cabling issues. Consider safety practices. Always follow safety precautions when working with electrical and data cabling systems. Wear appropriate personal protective equipment and follow lockout-tagout procedures when necessary. Regarding grounding and bonding, firstly, understand the importance of grounding. Grounding provides a path for fault current to return to the source, helping to protect equipment and personnel from electrical shock hazards. Secondly, identify grounding points. Locate the main grounding electrode for the building and ensure that all telecommunications grounding systems are properly connected to it. Thirdly, bond metallic components. Bond all metallic components of the cabling system, such as cable trays, conduits, and equipment racks, to the grounding system to create a low impedance path for fault current. Fourthly, use appropriate grounding conductors. Use appropriately sized grounding conductors to connect equipment and cabling systems to the grounding system. Refer to the National Electrical Code, Article 250. Fifthly, test grounding connections. Verify the integrity of grounding connections using a ground resistance tester. Regarding cable types and categories, firstly, understand the differences. Learn the differences between various cable types, such as unshielded twisted pair, or up shielded twisted pair, or STP, and fiber optic cables, and their suitability for different applications. Secondly, choose the appropriate category. Select the appropriate cable category based on the required bandwidth and performance characteristics of the network. For example, Cat6A cable supports higher bandwidths than Cat5e cable. Thirdly, consider shielding. Consider using shielded cables in environments with high levels of electromagnetic interference to minimize signal degradation. Fourthly, inspect cables for damage. Before installation, inspect cables for any signs of damage, such as cuts, kinks, or abrasions, which could affect performance. Fifthly, follow bend radius requirements. Avoid bending cables beyond the specified bend radius, as this can damage the conductors and degrade performance. Regarding cabling standards, firstly, familiarize yourself with TIA 568. Become familiar with the TIA 568 series of standards, which provide comprehensive guidelines for structured cabling systems. Secondly, understand cabling distances. Adhere to the maximum cabling distances specified in the standards to ensure proper signal transmission. Thirdly, follow termination standards. Follow the recommended termination procedures and pin assignments outlined in the standards to ensure proper connectivity. Fourthly, use certified components. Use cabling components that are certified to meet the requirements of the relevant standards. Fifthly, document cabling installations. Document all cabling installations, including cable routes, termination points, and test results for future reference in troubleshooting. Regarding testing and certification, firstly, use appropriate testing equipment. Use industry-standard cable testers to verify the performance of data cabling installations. Secondly, perform continuity testing. Perform continuity testing to ensure that all conductors are properly connected and that there are no opens or shorts. Thirdly, measure signal parameters. Measure signal parameters such as attenuation, near-end crosstalk, or NEX, and return loss to verify that the cabling meets the required performance specifications. Fourthly, generate test reports. Generate test reports that document the test results and provide evidence of compliance with the relevant standards. Fifthly, certify cabling installations. Certify cabling installations that meet the required performance specifications and provide documentation to the customer. Regarding network topologies, firstly, understand the basics. Understand the different types of network topologies such as star, ring, bus, and mesh, and their advantages and disadvantages. Secondly, choose the appropriate topology. Choose the appropriate network topology based on the requirements of the network, such as scalability, reliability, and cost. Thirdly, design cabling layouts. Design cabling layouts that are optimized for the chosen network topology. Fourthly, consider redundancy. Consider implementing redundant cabling paths to improve network reliability. Fifthly, document network topologies. Document all network topologies, including cabling layouts and device locations, for future reference and troubleshooting. Regarding Ethernet standards, firstly, understand Ethernet speeds. Understand the different Ethernet speeds, such as 10 megabits per second, or Mbps, 100 Mbps, 1 gigabit per second, or Gbps, and 10 Gbps, and their cabling requirements. Secondly, choose appropriate cabling. Choose cabling that is appropriate for the required Ethernet speed. For example, Cat5e cable can support speeds up to 1 Gbps, while Cat6e cable can support speeds up to 10 Gbps. Thirdly, follow cabling guidelines. Follow the cabling guidelines specified in the Ethernet standards to ensure proper performance. Fourthly, use appropriate connectors. Use appropriate connectors for the chosen Ethernet standard. For example, RJ45 connectors are commonly used for Ethernet connections. Fifthly, test Ethernet connections. Test Ethernet connections to verify that they meet the required performance specifications. Regarding Power over Ethernet or PoE, firstly, understand PoE technology. Understand how PoE technology allows you to power devices over data cables. Secondly, determine power requirements. Determine the power requirements of the devices that will be powered over Ethernet. Thirdly, choose appropriate PoE switches. Choose PoE switches that can provide sufficient power to the connected devices. Fourthly, use PoE-compatible cabling. Use cabling that is compatible with PoE technology. Fifthly, follow PoE standards. Follow the PoE standards to ensure proper operation and safety. Regarding cable management practices, firstly, plan cable routes. Plan cable routes to minimize congestion and interference. Secondly, use cable trays and conduits. Use cable trays and conduits to organize and protect cabling. Thirdly, label cables. Label cables clearly and consistently to facilitate identification and troubleshooting. Fourthly, use cable ties and straps. Use cable ties and straps to bundle and secure cables. Fifthly, maintain proper bend radius. Maintain proper bend radius to avoid damaging cables. Regarding troubleshooting techniques, firstly, use troubleshooting tools. Use troubleshooting tools such as cable testers, voltmeters, and turn generators to identify and diagnose cabling problems. Secondly, check connections. Check all connections to ensure that they are secure and properly terminated. Thirdly, test for continuity. Test for continuity to identify opens and shorts in the cabling. Fourthly, measure signal levels. Measure signal levels to identify signal degradation and interference. Fifthly, isolate problems. Isolate problems by systematically testing different sections of the cabling. Regarding safety practices, firstly, follow electrical safety procedures. Follow electrical safety procedures to avoid electrical shock hazards. Secondly, use personal protective equipment or PPE. Use personal protective equipment such as gloves, safety glasses, and insulated tools. Thirdly, de-energize circuits. De-energize circuits before working on cabling systems. Fourthly, use lockout-tagout procedures. Use lockout tagout procedures to prevent accidental re-energization of circuits. Fifthly, follow safety regulations. Follow all applicable safety regulations and standards. By pursuing these educational resources and adhering to industry best practices, electrical contractors can confidently expand their services into the realm of data wiring and structured cabling, meeting the evolving needs of their clients and enhancing their business opportunities.